Good evening, everyone. Welcome to lecture number live section of 6 of NPTEL course of Mechanics of Material. My name is Vaibhav Gupta, and today I'll be giving you the hands-on experience for the problems which will be deal with the week 6 lectures. So, first of all, I'll give you the recap that what we have studied so far. So, today's date is 4th. So, I'll give you the summary of just a brief summary of what we have studied from week 1 to week 5. So basically, we have seen four concepts involved in mechanics of material. What are those? That first is force, which is indirectly related to displacement. We cannot relate force and displacement directly, so we need two additional quantities. What are those? That are nothing but strain and stress. Okay. So these are the force quantities that we have looked upon in brief. So how they are related with the help of equations? We have seen all the derived version of all the equations. The displacement and strain. Displacement is related to strain with the help of displacement gradient. We write linearized strain as half of H plus H transpose. That is how displacement is related to linearized strain. How strain is related to displacement? We have seen with the help of compatibility condition. This is nothing but curl of epsilon. This is how strain is related to displacement. Sorry, I made the arrows in opposite directions. So the displacement is related to strain with the help of displacement gradient, and strain is related to displacement with the help of compatibility condition, which is nothing but curl of epsilon. So now, next we have seen that how stress has been related to force is nothing but with the help of equilibrium equation. It is nothing but divergence of sigma plus rho b. B is nothing but body forces, which is equal to rho a. This is how stress and force are related with the help of equilibrium equation. Okay. Now, finally, we have seen that how stress and strain are related. They are related with the help of constitutive relation. And we have seen the basic case of Young's modulus that sigma is nothing but E into epsilon, where E is nothing but your Young's modulus, which comes from a uniaxial experiment. Okay, this is all we have seen from 1 to 5th week, and this all we have seen in a detailed way. So these are just the summary that I have given to you. So now the next in week 6 is that we will apply all these equations to solve a boundary value problem. So suppose before moving to solving the boundary value problem, I'll just give you some tips like how to solve these things. So first of all, how do we write stress in terms of strain with the help of Lemmy's constant? So stress is nothing but lambda times base of epsilon plus 2 mu epsilon. Okay, where lambda and mu are Lemmy's constant. Okay, next is how we relate strain to stress with the help of Poisson's ratio and Young's modulus of elasticity. Epsilon is nothing but 1 plus mu upon E into sigma minus mu upon E trace of sigma into I vector, I matrix. Sorry. So where nu is equal to Poisson's ratio, which is nothing but the ratio of my negative of transverse strain upon axial strain. This is also we have seen with the help of uniaxial experiment we can derive. And E is nothing but modulus of elasticity. So this is a two-way in which we can relate stress to strain with the help of Poisson's ratio or Lemmy's constant. Okay, this will help us to find the stress matrix when the strain is given or strain matrix when the stress is given. Okay, so this is what the formula to be required. Now in week 6, what specifically we have seen is that in week 6 is that there are various reasons why we observe strain. Okay, so what we are observing is known as observed strain. Okay, this is nothing but a combination of various strains. For example, mechanical strain plus thermal strain plus so on. For this course, only two types of strain are required. That's why I have only put that epsilon mechanical strain and epsilon thermal strain. Okay, so what we have seen in above these two formulas, which I have tick marked right now, is that this is nothing but we are calculating the mechanical strain and mechanical stress. We only relate the mechanical strain and mechanical stress. So suppose now, if I take an example of a beam which have a fixed end in one end, and we have heating the body, and this is at 20 degrees Celsius right now. Okay, and now I will heat the body, and the temperature has been raised to 40 degrees Celsius. And suppose it has a length of L at 20 degree, and this has a length of L at 40 degree. Okay, so this symbol is for heating. Okay, so what is our strain observed here? Is nothing but the change in length by original length. Change in length is what? Length at 46 degrees Celsius minus length at 20 degrees Celsius divided by length at 20 degrees Celsius. This is what we have observed the strain here. Okay. Okay. Now suppose I will take another body. Okay. In this body, it is fixed at both the ends. And I will now start heating this body. Okay. So did you observe any change in strain here? Since both the ends are fixed, the body cannot change its length. Okay. So here our epsilon observed will be equal to 0. And since epsilon observed is nothing but a combination of epsilon mechanical plus epsilon thermal, so our epsilon mechanical here will become negative of epsilon thermal. Okay. So now how we define the strain in thermal? The formula to define the strain in thermal is epsilon thermal is nothing but alpha delta theta into I. Okay, where alpha is nothing but the coefficient of thermal expansion. Okay, I is the identity matrix. And delta theta is the change in temperature. This is how we define strain in thermal. Okay. Now we'll see one more formula which will help you directly relate the stress and strain. Okay. Remember, these two formulas which I have marked ticked, all the formulas which relate stress and strain are all mechanical. Okay. Why I am focusing on this point? Because in solving the questions you cannot confuse like what you are observing and what you are calculating. Okay. So suppose I take an axial member. Okay. Suppose this is the member and a load is applied. P is load is applied here. So what is the state of stress? It's nothing but a uniaxial state of stress. P by A, and in other directions also 0. So in epsilon, what we observe, this we have seen in earlier videos also, is nothing but delta B by L, 0 0 0, delta T transverse in y direction by H, 0 0 0, and delta transverse in z direction by the corresponding length change, that is B. Okay, so how you will relate stress with strain? Sigma xx will be nothing but will be equal to P by A, which is equal to E epsilon xx. Okay, which is nothing but E into what is epsilon xx? Delta B by L. Okay, so now delta B is nothing but PL over AE. So now this is the formula which we will be using to solve the problems. Okay, remember this formula is only applicable when the stress is uniaxial state of stress. Okay, now I'll move to the problem solving. We'll see first 6 basic examples which has already been covered in the lectures also. I'll explain you once more all these 6 examples and then I'll tell you about by putting the values how to solve these different problems. Okay, but first of all we'll see 6 different cases. Okay, so moving ahead, case 1. Okay, suppose we have a step shaft thing like this. Okay, so I'll point it out as A, B and C. So AB has an area of 2A, modulus elasticity as E. Okay, for BC we have area as A and modulus elasticity as E only. Okay, now only at B point a force has been applied here. For betterment I'll put force here, P. Okay, so now these all cases are I'm solving first 3 cases I'll solve without heating. So without heating means there is no role of thermal strain as change in temperature is 0. Understood? So first 3 case I will solve you without heating and next 3 case of similar type I will solve with the help of heating when we heat the thing. Okay, so these are without heating. So now if we are not heating, so our formula that we have proposed above is epsilon observed is nothing but epsilon mechanical plus epsilon thermal. So now since epsilon thermal is 0, so what we will observe here will be equal to nothing but epsilon mechanical. Understood? Okay. Okay. So now coming back to the problem. So suppose the length of AB is 2L and length of BC is L. Okay. So for all this type of problem, I always suggest you to go ahead with the first step as free body diagram, because without the help of free body diagram, you cannot move further. Okay. So I'll tell you step by step how to draw free body diagram. Okay. For this problem, we'll draw free body diagram. Okay, from next time I will write as FBD, free body diagram as. So we'll just separate the element as A, B and BC and find out the forces. Okay, this is AB and this is smaller one is BC. Okay, this length is 2L and this is L. It is given in the question. It has a modulus velocity E, area A. AB has modulus velocity E and area 2A. Now we have said in the question that it is without heating, first thing. Second is the force has been applied in B. Okay, so force is applied on B only. So since a force has been applied on B only and due to the third law of Newton, the similar opposite force has been applied will be applied on A like this. Okay, and since the force has been applied, the body AB will move to certain delta B. Okay, some changes then will be seen in delta B. Okay, so now we'll move to BC. No force has been applied on BC, so we'll put zero force there. But since B is reflecting to delta B, sorry, changing its length to delta B, so BC also will change its length to delta B. And since BC is changing at delta B, C point also moves by delta C point. Okay. So now this is the free body diagram. Okay. Now first we'll solve for AB. Okay. For AB. Now above we've seen this formula. This formula which I have taken the mark here right now. Okay. For uniaxial state of stress, delta B is nothing but PL over AE. So delta B here will be equal to PL. L here is given as 2L. Area is given here as 2A and E as E. So delta B will be nothing but PL over A. Okay, 1 second. Sorry for the pause. Sorry for the delay. Some urgent work has come. So where we are? So delta B. So from the formula that we have seen, delta B, which is equal to PL over AE for the uniaxial state of stress that we have derived with the help of this tick mark. You can see with the yellow tick mark. So here delta B is nothing P. Length for AB is 2L, area is 2A, and E is E. So delta B is nothing but PL over AE here. Okay. So this is nothing but change in length for that particular body AB. Okay. Now we'll go to BC. Here change in length is delta C minus delta B because both have moved, so the relative change will be delta C minus delta B. Okay, which is nothing but P. Here L is L, area is A, E is E. Am I correct here? No. Why? Because P here is 0 as no force has been applied at the point BC. Okay, you can see with the help of this free body diagram. Okay, so here delta C minus delta B is nothing but 0 and hence delta C will be equal to delta B. Okay. So what we have learned with this problem one is that when the force has been applied only at the point B and not on the point C, and the case is not heating. Okay. So the delta C is nothing but equal to the change in length occurred at delta B due to the force applied at point B. Understood? So this is case 1. Now I'll move to case 2. Okay. So what is the case 2 will say here? Same thing without heating will take first case. Okay. I'll write here also after making diagram. Suppose same thing AB and BC. Okay. And now here's some one support. Okay. And this is nothing but gap given, which is equal to delta. Okay. Here. Okay. So, okay, this is the third case. I'll first solve the another case, then we'll move ahead to this case. Okay, now this is the body ABC. Now here, same specification like modulus velocity E, area 2A. For BC it's E and area A. Length is 2L and for BC length is L. Okay, now suppose last time we have applied force at B, P. Here we apply a force F at C point. Okay. Now one force is acting at B point and one force is acting at C point. Okay. Now again we'll draw a free body diagram for both the cases. This is also without heating. Okay. Which means epsilon thermal will be 0. Okay. Now we'll make a free body diagram for AB and BC. Okay. Now since F is applied at C point, so due to the third law of Newton's, similarly opposite force will be applied at B point. Okay, F. Okay, to maintain the equilibrium. Okay. Now since to maintain equilibrium at point B only, so this is the force which is originally applied. But since one new force F comes to maintain the equilibrium at for BC, equal and opposite force F will act at point B of AB. Okay, so this overall will becomes P minus F in this direction. Okay, and to maintain the equilibrium at A point, similarly P minus F will act. Okay, got the point? Okay, so similarly we'll write, see with the application of this members has a change in length of delta B. So for BC, delta B it will shift. Similarly, it will shift to delta C. So now this is the free body diagram, FBD. So now applying all the things, delta B is nothing but P. Here P is nothing but P minus F. L is 2L. A is 2A and E is E. So delta B will become P minus F into L by A E. Okay, this is delta V. So now for BC, relative changes delta C minus delta B. What is the force applied? F. L is L here, A is A and E is E. This is nothing but, see here negative will come. Why? Because F acts as a compression. For tension we take as positive, for compression we take as negative. Okay. Why we didn't took minus of P minus F? Because at AB this is going towards the tension side. Okay. So that's why P minus F. So coming to the BC, Delta C minus delta B will be nothing but minus FL over AE. Okay. So delta C is nothing but delta B minus FL over AE, which is nothing but delta C will be equal to PL by AE minus 2FL by AE. Putting the value of delta B here, we will get delta C as this. So this is case 2. Okay. Next we'll go to case 3. Okay. So what case 3 says? Same thing here. Non at point B, A, B, C. Okay. Same thing E, 2A, E, A. Length 12, length L. Okay. Now here one support has been given here, and this is delta gap. Okay. And a force has been applied at B point only, and it is asked like find, and asked the question has been asked like find F to be applied at point C such that no gap is left. Okay. So what this question means is that we have to apply some force F at C point such that the delta C will become delta gap. It should enclose the gap. Okay. So what we can do here is that we assume that it closes the gap. Okay. Here. Okay. So then if it closes the gap here, so it sticks to the fixed point. So the fixed point will apply some opposite force because it's closing the gap. So it will move away. So it will apply a compressive force of F here. Suppose the compressive force is F. Let's say. Okay. So we have to find the value of this F. Okay, because we are closing the gap. Already a P force has been applied. Okay. So how we'll do this case? We'll see here. Okay. Suppose I will draw the free body diagram. First for AB, E to A, length 12, BC. Okay, length is L. Okay, E, A. Okay, now since F is applied at C point, because we have closed the gap to find out the, because it is asked in the question to find the force so that the gap is not left. So it becomes similar to a case 2 problem. Okay, all the free body diagram are similar to case 2 problem, but one change will be there. I'll tell you. See, this F is applied. So then, for to maintain equilibrium, this F should be applied at B point. So here already P has been acting, but since we applied a force to maintain the equilibrium at point B of BC, so due to third law of Newton, a similar opposite force F will be applied here. So this nothing but will be in positive excitation P minus F, and to maintain the equilibrium it will act at the other end A P minus F, similar to as case 2. So finally what we get from case 2 is delta B was P minus F L over AE, and delta C is equal to PL by AE minus 2 FL by AE. But here this delta C is nothing but this, because this has been given in the question. Okay, so this delta is equal to PL by AE minus 2FL by AE. Okay, now P given, A given, E given in the question, and delta also given in the question. So what is left? F. So substitute, just put the value here. So F will become, what F will become now? 1 by 2 P minus delta AE upon L. Okay, this is the value of F we will get. Okay, just understand one thing. Here we have assumed that force to be compressive. See, only when the gap will be closed, the fixed support will give a reaction that is always opposite to the closing of the gap. So this is always be compressive. This cannot be tensile. So the force value what we have assumed should always be greater than 0. Okay, if it's coming out F less than 0, it means the value of S is equal to 0. You have to put. This has been better explained in the lecture also, you can see. Okay. Now these three cases we have assumed for without heating cases. Okay, all three cases. Now I will see, I'll do all these three cases again for the heating case also, where your epsilon observed will now be equal to epsilon mechanical plus epsilon thermal. Previously in these three cases, the observed what we are observing here, delta B as observed, is nothing but the epsilon mechanical. Okay. Now with heating I'll write here. With heating means epsilon thermal is not equal to 0. Okay. So now again we'll do it. Case 1. Okay. Same one. Okay. E 2A, but now with this alpha will also be there. Coefficient of thermal expansion. Okay. This is bar AB. This is BC. For BC, it's EA alpha. Okay. Only we are heating this time. No force has been applied. No force applied in this case. Okay. So now again we'll draw free body diagram. See why I am drawing free body diagram again stepwise is that because this is the most important step to see how we have to proceed further. Okay. Member AB, member BC. Okay. It has, I forgot to mention the length, 2L and L for BC. So here for member AB, E 2A alpha. Okay. Length is 2L. Okay. It will change its length due to heating delta B. Okay. No force is applied, so I didn't mention any force. Now we go to BC. It has E, A, and coefficient of thermal expansion is alpha. Again, no force, so I didn't mention any force. Length is L. So B has reflected delta B due to AB, and this member will reflect to delta C. Okay, at C point, not deflected, changes length. Sorry. Okay, so now we'll check one by one. Okay, now here, what we check is epsilon observed is nothing but epsilon mechanical plus epsilon thermal. Okay, so for case BC, we'll do for BC. Epsilon observed is nothing but relative change in length. That is delta B minus delta C minus delta B by L. Change in length by original length. This is observed, which is nothing but epsilon BC mechanical plus epsilon thermal. Okay, this is nothing but PL over AE that we have seen earlier, how to calculate mechanical strain for uniaxial state of stress. And since P is 0 for BC case, this epsilon mechanical will become 0. Okay, now we are left with delta C minus delta B by L, which is equal to epsilon thermal. And I've given you the formula of how to calculate epsilon thermal is nothing but alpha delta theta. Okay. So delta C minus delta B will be equal to alpha delta theta into L. Okay. Many of you might be thinking that where I left this I. Since we are computing only one component here, that is epsilon xx. So I've taken only one value. That's why no matrix has been required now. When we are calculating a matrix, then I will be required. I'll show you with the examples, this thing also. Okay. Now we go to BC. In BC, epsilon observed is delta B by change in length by original length, which is 2L, which is equal to epsilon AB mechanical plus epsilon thermal. That is also AB. Here BC. Okay. So here also epsilon mechanical is nothing but P into 2L by 2A into E. But since P is again 0 here as we didn't apply any force, so epsilon mechanical becomes 0 here in this case. Okay. So again, now our epsilon observed will be equal to epsilon thermal, which is nothing but delta B by 2L. Will be nothing but alpha delta theta. Okay. Hence, delta B will be equal to 2 alpha delta theta into L. And putting in this equation delta B, our delta C will become 3 alpha delta theta into L. Okay. I hope you got it. This thing. Okay. Next I move to case 5. Okay. Same those two bars A, B and BC. Same this thing. Again a gap has been left here. Gap which is equal to delta given. Okay. This is given to us. Okay. Again no force has been applied. And the property is given as E 2A alpha because heating, this is all the case for the heating. This is E A alpha, length is 2A 2L, sorry. For BC length is L. A, B and C. Okay. Again they have asked that find the force F to be applied such that no gap should be left. Okay. So again what we'll do, just like we have did in the last case, we just fill the gap here. So when we are filling the gap, what is there? This point will give a compressive force of F because we are pushing BC, ABC to close the gap. Okay. Okay. So A, B and C. Okay. So now this is E, this is 2A, this is alpha, this is E, A and alpha. Okay. Length 2L. Okay. Length I will not write because now change in length has occurred. So now I will draw free body diagram. What is free body diagram now here? A, B and B, C. Okay. Is E 2A alpha, length 2L. Okay. It will change its length to delta B. Similarly delta B here, delta C here. Okay. Length is L for this. Property is E, A and alpha. Okay. Now F is applied due to closing of gap. So to maintain equilibrium, F will be applied here also. And since F is applied at point B, to follow the Newton's third law, opposite force will be applied at AB at point B. and to maintain equilibrium at A point F will be applied. Okay. So again now epsilon observed is nothing but delta B by 2L is equal to AB mechanical plus AB thermal. Okay. So now here, what is epsilon mechanical here? This is PL over AE. P here is F. This time this won't be 0 because F is coming into the picture. In last case, it is 0 because no force has been applied. So what is epsilon mechanical is nothing but PL over AE. P here is given as F. L is 2L. A is 2A. And E is E. Okay. So what it will become? Delta B by 2L. It will be equal to FL over AE minus. Okay. Why this minus? Because compressive force has been acting. Minus AE plus alpha delta theta. Okay. So delta B will become minus 2FL by AE plus 2 alpha delta theta. Okay, this is for AB part. What about BC? Similarly, epsilon observed will be equal to epsilon BC observed mechanical plus epsilon BC thermal. Okay. Here what is observed? Related change in length, what is equal to delta C minus delta B by L. Here epsilon mechanical will become again a compressive force of F. So minus F, length is L, area is A, and E is E plus alpha delta theta. Okay. So delta C will become, sorry, see I did a mistake. Okay. What is the mistake here? Can anyone tell? See here, I have to take the value of change in length by original length I am taking. Okay, so L won't be there. So I have to take only one type of side L. Okay. Okay. Okay then. Fine. So this L won't be there. If I am taking L here, here L won't be there. Here it will be there. Okay, I cannot take it two times. Okay. So delta C will become here now. What delta C will become here? It becomes minus 2FL by AE plus 3 alpha delta theta into L. Okay. Now this delta C has been given as this. It is given in the question. So from this we can find out the value of F similar to what we have found out in previous cases. Okay, these are the 5 cases which we have seen so far. Okay. So just now Arnav has been joined. So Arnav, what we have seen so far is that I'll just give you a recap of so far what we have covered in this live section is that first we have studied the summary of first to 5 week is that 4 concepts have been given: force, displacement, strain and stress. We have defined each of them properly and derived the expressions which are relating to them, such as displacement relating to strain with the help of displacement gradient, stress to strain with the help of constitutive relation, and force to stress to equilibrium equation, which is nothing but divergence sigma plus rho equal to rho A. Okay. Then we see like there are various reasons that we observe strain, which are nothing but observed strain is nothing but a combination of mechanical and thermal strain. Actually, there are many more, but for this course, only 2 are required. Am I audible?
Yes, sir.
Okay. So then we have seen the cases that has been done in the lecture only. Just for you to understand better, I am covering all those cases again. Okay. So first we have seen 3 cases which is without heating, and then we have seen 2 cases due to heating. Without heating means epsilon thermal will always be 0. So what we are observing, which will be equal to mechanical strain. Okay, and what we relate in our concept is stress and strain. They both are nothing but mechanical stress and mechanical strain. Okay, so so you can check after this session that what have been done, so to get a more clear idea. So now the last case is this. Last case is for the composite one. What is composite is nothing but a combination of steel plus concrete. Okay, a cylinder has been given to us. Suppose in the example, I'll take just the example. This is a rigid plate. I'll draw correctly more. So this is a rigid plate given. It is supported by two steel columns like this. The bottom is fixed. This is also a plate which is fixed. Okay. So here this is the steel columns. Steel here. And inside is filled with concrete. Okay. So suppose I applied a force of P here. Okay. So when a force P is applied, base is fixed, it won't move. Only first rigid plate will move, and this will, since we are not taking effect of Poisson's ratio, all steel and column will move in a downward direction with the same amount. Okay, this is nothing but delta. Okay. See, the Poisson's ratio of concrete and steel are different, but here we are making an assumption that Poisson's ratio will not affect anything. Okay, the concrete will not bulge out in any other direction. So if we are applying a force of P here in a downward direction, the whole system, steel plus concrete, will move down with the amount of delta. Okay, so how we will calculate this delta? This is what we have to see. Okay, got it? So we have seen that for a uniaxial state of stress, sigma is nothing but E into epsilon. Okay. And suppose for this case, sigma matrix has been given to you since it's a uniaxial state. I define my coordinate system as Z, Y, and X. So we are applying in a Z direction force. So it will nothing but P here. And epsilon matrix will get us delta by whatever the height we will assume, L. Suppose we will say L, this thing. Okay, see, this won't be zero, these all things. Okay, when we consider the effect of Poisson's ratio, these are taken zero deliberately by taking an assumption that Poisson's ratio is not into the picture. It's not taken into account. Since you joined midway, are you understanding something?
Yes, sir.
Okay. Your voice is feeble today.
Hello.
Yeah, fine now. Okay then.
Sir, यहाँ तक lecture में देख.
Yeah, just this is the last case, and then we'll move on to the question solving part. Okay.
Okay.
So now we see that stress is related to E into epsilon. So here, since both steel and concrete are deflecting by a same amount, so epsilon ZZ in concrete will be equal to epsilon ZZ in steel because both are moving by same amount, which is nothing but delta by L.
Delta by L.
Okay. Now since stress is related to strain with the help of E, so stress in concrete will be equal to E of concrete into epsilon, which is nothing but E concrete into delta by L. Similarly, E of sigma of steel will be equal to E of steel into delta by L. Okay. Now we know since this is a rigid plate and P force has been applied. So both will push forward this thing oppositely, concrete and steel. So concrete will put a force of F concrete and steel will put a force of F steel because we are just pushing them downward. So they will also react. So what is the equilibrium if we write? F of concrete plus F of steel will be equal to P. If we write force equilibrium. Okay. So F of steel is nothing but sigma into A. So what we have calculated? F is nothing but sigma into A because a uniaxial we can directly relate. So F concrete plus F steel, how we'll write? Sigma of concrete. Sigma of concrete is nothing but E of concrete delta by L into A of concrete plus E of steel delta A of steel by L, which is equal to P. Okay. Just take all these things common. Delta will be equal to PL upon E concrete A concrete plus E steel
plus A.
E steel. Okay. I said it another way. Okay. So now we know delta. So you can calculate stresses also. E of steel will be equal to P into E of steel upon E steel A steel plus E concrete A concrete. Okay. And sigma of concrete will be P into E concrete upon E concrete A concrete plus E steel A steel. Okay.
Yes, sir.
So these are the 6 cases we saw in the week 6 lectures. Okay. Now we move forward to the problem solving thing. Okay.
Yes, sir.
Question 1. Okay. Suppose a ABC bar has been given, which is fixed at A. Okay. A, B, and C. Okay. And a gap has been given to us, which is equal to nothing but 5 mm. Okay. And a force P has been applied at point B, which is equal to 300 kilonewton. Okay. Length of A is given as 2 meter. And length of BC is given as 1 meter. Okay. Other details given as dia of AB 20 mm. You can also write dia of BC equal to 10 mm. Modulus velocity for AB is 100 GPa. Okay. And modulus of velocity for BC is 70 GPa. Alpha for AB, coefficient thermal expansion, is 20 into 10 to the power minus 6 per degree Celsius. And alpha for BC, 25 into 10 to the power minus 6 per degree Celsius. Okay. And delta theta is 20 degrees Celsius. Here we have to find out delta B. Okay. Stress as BC and stress at AB. So as no gap should be left. No gap should be left. Okay. Remember, when nothing is mentioned in the question about heating, so assume delta theta to be equal to 0. This will help you to solve the assignment also, first question. Okay. When delta theta is given, then only you have to take the account of thermal strain. Okay. So now as we
same problem.
yeah, but they are not mentioned for the thermal expansion. So thermal strain you have to keep 0. I'll tell you. Now what we have studied so far, that epsilon observed will be equal to epsilon mechanical plus epsilon thermal. Okay. Here epsilon thermal will be in the picture because we have given delta theta. This has been given. Wherever the delta theta has not been given, this comes out to be 0 when delta theta is equal to 0. Okay, got it?
Okay, sir.
Okay, so now for this case, this is the formula, okay, that we are looking for. Now it is said find all these things when the gap is closed. Okay, so now again we'll draw the free body diagram. Okay, AB and BC. See, when this gap will be closed, as said you, this fixed point will push this CB to F force. Okay, because we are closing the gap and pushing the fixed support. So that fixed support will give the reaction in the form of some force. That force we say is F. Okay, because we are filling the gap. Suppose you are putting your finger on the wall, you are pushing the wall, but wall will not be pushed. You are also getting an equal and opposite reaction, but the gap is closed. Got the point? So that force the fixed point is applying is F. So here, after closing the gap, we are getting a force of compressive force F. So to have the equilibrium maintained, B will also get a point, force F. And C, since B got a force F for BC member, AB member, we will get an equal and opposite force F because of Newton's third law at point B. And since A is fixed, to maintain equilibrium, we'll get a force F at A. Okay. So now what are the specifications given to us? E has been given to us, EAB, we write as EAB. Area AB has been given to us, and alpha AB has been given to us. Length is 2L, sorry, not 2L, 2 meter here. Here length is 1 meter. Here EBC has been given, area BC has been given, and alpha BC has been given. Okay. Now we'll first, since the force has been applied, it will change some length to delta B. And since delta B has been changed here, so it will affect BC also, delta B, and C point also moves to delta C. Okay. So now first we check for AB. Epsilon observed is equal to epsilon mechanical plus epsilon thermal. Okay. What is observed here? Delta B change in length. What is the original length? Original length is nothing but 2 meter. It is nothing but applied force F. Okay. I missed one thing you didn't also mention. We applied the original force of 300 also here. So 300 is already acting at B point. Okay. So overall force is acting towards positive X direction, which has a magnitude of 300 minus F. Okay. So here at A also we will be getting a to maintain equilibrium condition. We will get a this force, which is equivalent to 300 minus F. Okay. So now coming to this thing. So epsilon mechanical. Epsilon mechanical is nothing but PL over AE. Here P is nothing but 300 minus F. A given as pi d square by 4 because diameter of AB has been given. Okay. Sorry.
Plus, no?
This is minus. See. F is acting towards negative X direction here.
Okay.
And 300 is acting towards positive X direction. We take a equivalent of 300 minus F in the positive X direction. Okay.
Okay, sir.
And since it's a tensile force, we take here in the formula positive only. Okay. While writing the expression 300 minus F is positive. So what is epsilon mechanical? It's nothing but P upon AE. Okay. So P is nothing but 300 minus F here. A is pi d square by 4. okay, into E of AB. Okay, I will just write the expression below with the values. What is thermal? Thermal is nothing but alpha delta theta. Alpha AB has been given to us and delta theta. Okay, delta theta is 20 degrees Celsius given. So now putting the values in the formula, 300 minus F upon pi 20 square by 4. Okay, since dia is in mm, we all convert this mm to meter. Okay, so 1 meter is equivalent to 1000 mm. Okay, d square means mm square. So 1 meter square will be equal to 10 to power minus 10 to power 6 mm square. So now we are converting mm square to meter square. So 1 mm square will be equal to 10 to the power minus 6 meter square. Okay. So we'll just multiply by 10 to the power minus 6 to convert from mm square to meter square, since all the units are in meter. Okay, and kilonewton. Similarly, we'll change the E also. E given as for AB is given as in the question 100 GPa. So EAB is 100 GPa. Okay, this is nothing but 100 into 10 to the power 9 PA. PA is Newton per meter square. Since force is given in kilonewton, so we'll change to 100 into 10 to the power 6 kilonewton per meter square. Okay, I will write for area AB also. Area AB is given as pi d square by 4. This is pi into 20 square by 4 mm square. Okay, because diameter is in mm, which is nothing but pi into 20 square by 4 into 10 to the power minus 6 meter square. Okay, you should be consistent with units. Okay, and force is already given in units, kilonewton. Okay, plus I'll write this 10 into 100 into 10 to the power 6 plus alpha is given as 20 into 10 to the power minus 6 into 20. Okay, so now this expression will calculate here as delta B is nothing but 2 into 300 minus F upon. Okay, if I open the area 314.159 into 100 plus 40 into 10 to the power minus 6. This is the first expression for AB member. Okay, we did for AB member. Now we go to BC member. Now for BC member, our free body diagram is this. Since compressive force is acting F, so we write epsilon mechanical S minus F upon AE. Okay, so what is epsilon observed? Epsilon observed here is relative change in length, that is delta C minus delta B by length of BC is 1 meter. What is epsilon mechanical? Minus P. P is nothing but F. F is given here in the question. This is F applied. Okay. So minus F upon A. A is pi. D given as 10 square by 4 into 10 to the power minus 6 for meter square. E is given as 70 GPa. So which is nothing but 70 into 10 to the power 6 kilonewton per meter square. Okay. This is epsilon mechanical plus alpha. Alpha given as 25 into 10 to the power minus 6. Okay. Okay. We'll take 20. Okay. Both alpha are same. We'll take both alphas to be same. In the question you change alpha. This thing. BC also 20. Okay. So alpha is 20 into 10 to the power 6 into delta theta is 20. Understood this thing, this expression, or shall I write it step by step?
Yes, sir.
So epsilon thermal is nothing but alpha delta theta. So alpha is given this, delta theta is 20 given this, okay? Epsilon mechanical is nothing but minus F upon AE. A is area of circle is pi d square by 4. Okay, D is 10 mm. So we put the value of D, which convert the unit to meter square. That's why we multiply by 10 to the power minus 6. E is given as 70 GPa. E, which is equal to 70 into 10 to the power 9 PA. That is Newton per meter square. Since force is given in kilonewton, we'll write as 10 to the power 6 kilonewton per meter square. Okay, that's why we wrote 70 into 10 to the power 6. Okay.
Okay, sir.
So now we'll write. So this is equation number 2. I'll write again this equation. Delta C will be equal to delta B minus F. See this, I will take it to this side now. Okay, right hand side. Minus F upon 78 upon, I will just write the calculate expression 539 into 70 plus 40 into 10 to the power minus 6. Okay, this expression we got. So now delta C, see, since we close the gap, our delta C is nothing but equal to this thing, gap. Gap is nothing but given as 5 mm to us, which is nothing but 0.005 meter. Okay. Okay.
Okay.
So now, after putting this value, we got expression this as 2. Okay. So using equation 1 and 2, see here only F is unknown. Okay, F and delta B's are unknown. In equation 2, equation 1 and 2, delta B and F are unknown. Okay, and you have two equations. You can solve to find delta B and F. Okay, so when you use these two equations, this second and first equation, this equation, okay, equate delta B, okay, here to this expression 2. Okay, you will get the value of F as 66.722 kilonewton. Can you do this thing or shall I do it for you?
So कैसे why?
This expression 2 equation, you got it?
Yes, sir.
So after 2, you know the delta, this is there, delta B. Delta B we found in expression 1. This,
Yes, sir. Yes,
just put the value of delta B here.
Yes, sir.
So this expression will only have F as unknown. Other things are known to you.
Yes, sir.
You can find value of F.
Yes, sir.
So that is what I have found out to save time. Okay.
Yes,
And now when you put this F value in equation 1, in equation 1, this F value if you fill, you can find delta B.
Delta B, yes, sir.
So delta B is nothing but here I have found to you 14.9 mm. You can check with you, okay, with yourself. Since I have less time, that's why I have calculated for you. Okay. So these two you have found out, F and delta B. Okay. So now what are the stresses? Sigma AB and sigma BC. Stress is nothing but force upon area. So force at AB member is applied as 300 minus F. In the free body diagram we have seen. And area we have calculated for pi by 4 d square, which is nothing but for AB is 20 square. Okay. Into 10 to the minus 6 in meter square. Did you get this thing? No.
Yes, sir.
See, sigma is nothing but force upon area.
हाँ, ये stress है ना?
Yes. Force You can see in the free body diagram.
Yes, sir.
See, for AB force in the free body diagram, we have applied 300 minus F. So 300 minus F. Now you got the value of F. Just put the value here. Area you know only. Okay.
Yes,
So
sir.
sigma AB you will find as 742 MPa. MPa is nothing but, what is MPa? MPa unit is 742 Newton per mm square. Okay.
Yes, sir.
So here your area is in meter square and force is in kilonewton. You have to convert, okay, to this.
Yeah.
Got it? Similarly, sigma BC is nothing but minus F upon A.
Yes.
So F is 67.62.40, 66.722 we have found.
Yes, sir.
Area is pi by 4. D is 10 square into 10 to minus 6. It is in kilonewton per meter square. Okay. So sigma BC, which I got the answer is 862. Okay, it won't be exact. Newton per mm square. Okay, just convert the unit. This to years. Okay, you got this thing. So
Yes.
question 1 is for this thing. Okay. Now we'll move to question 2. Question 2 is very simple. Question 2 is there that I will write the question. The 2-meter concrete column having a square cross section. Okay, with 300 mm, side as 300 mm. Okay, with side as 300 mm is reinforced with 4 steel bars. Okay, each of,
सर ये 300 mm ये reinforcement अच्छा सर हो
no, this is a column size 300 mm.
Okay, sir.
Column, a concrete column. It's a square. Okay, so
ये
the cross section
reinforcement है ना
reinforcement is steel of 4 steel bars,
Okay, sir.
each of 20 mm dia. Okay, the column is placed between two thick rigid plate and 100 kilonewton axial load is applied, force is applied. Okay, so E of steel has been given us 200 GPa and E of concrete given to us 30 GPa. Delta we need to find out, and stresses at steel and stress at concrete. Okay, okay. Now to move for this question, first of all 2-3 things we'll calculate. Okay, see solution. First of all, what is the area of concrete? It's a square cross section. The square area is A square of side A.
Yes, sir.
So it is nothing but 300 square. This is concrete, okay? Square. This is 300. This is 300. And 4 steel bars are there. These are the steel bars. Okay? Inside concrete. Okay? So area won't be square, 300 square, because steel is also there. We have to minus the area of steel. Okay? You are getting my point?
Yes, sir.
And since 4 bars are there, so 4 into, what is the area of each bar? Pi by 4 into d square. D is 20 square. Okay? This is nothing but 90,000 minus 400 pi. Okay? Which is nothing but 88743.3 36 mm square. This is area of concrete. Understood? What is area of
Sir,
steel? Yeah.
एक कंक्रीट का फॉर्मूला लिखे हैं वो
A concrete is area of concrete. Okay. So see,
हाँ, तो उसका
area of
फॉर्मूला
concrete
लिखने
has
का
a
साइड
concrete has a cross section of square. So area of square is nothing but side square. Okay. But since 4 steel bars are there inside square cross section, we need to subtract that area. No, that only the concrete area will be there. So that's what we have subtracted.
Okay, sir.
So area of steel is 4 rebars are there, 5 by 4 into d square is nothing but 400 pi, which is equal to 1256. If I am not wrong, yeah, 0.63 mm square. This is area of steel. Okay, this thing, two things we have calculated. Okay, E of concrete is given to us, which is nothing but 30 GPa. It is nothing but 30 into 10 to the power 3 Newton per mm square. You know this units, how to convert. Okay, 1 Pascal is nothing but 1 Newton per meter square. Okay, got it?
Yes, sir.
And 1 GPa is nothing but 1 into 10 to the power 9 PA, which is equal to 10 to the power 9 Newton per meter square. So to convert this thing to mm, 10 to the power minus 6 you have to multiply. That's what, 10 to the power 3. And 30 is given, 30 into 10 to the power 3 Newton per mm square. Got it?
Yes, sir.
Similarly, E of steel is given as 200 GPa, which is nothing but 200 into 10 to the power 3 Newton per mm square. Same thing, okay, I did here. Okay. So now we know area of concrete, area of steel, E of concrete, E of steel. Okay. Now you remember I solved this case 6. I will show you this case 6. This case, composite case. This case and the question asked is same. So here we derived sigma of steel and sigma of concrete and delta also. Okay, this formula we have to use. Okay.
कौन सा?
This formula.
Okay, sir. Over.
Okay, you can look back at case 6 to know how we are deriving. Okay, I won't derive again and again. Okay, go back to case 6 while seeing this lecture again and just put the formula because other things are known to us. So delta is nothing but PL upon E concrete, area concrete, plus E steel, area steel. This is what we have looked here. See?
Yes.
Okay.
Sir.
So now put the value P is given to us as 100 kilonewton load is applied into 10 to the power 3. We converted into Newton. Okay. Length is given as 2 meter, which is nothing but 2000 millimeter. Okay.
Yes, sir.
E of concrete is 3 into 10 to the power 4 into 88 743 plus 2 into 10 to the power 5 into 1256. Okay. You can calculate delta from here. I didn't calculate it. You calculate by yourself. Okay. Okay.
Okay, sir. Okay.
Now sigma of steel will be nothing but P E of steel upon E concrete A concrete plus E steel A steel. Okay. Put the values of all these things and find sigma steel. Can you find?
Yes, sir.
Similarly, sigma of concrete will be P into E concrete. P given to you is 100. Okay. 100 kilonewton. So convert it into Newton. E concrete, A concrete plus E steel, A steel.
A steel.
So this is how you will find all these three things. Okay.
Okay, sir.
This is second question. Third question will go. Okay. Third question is that a steel plate E given to you as 200 GPa. Poisson's ratio is given to you as 0.3.
सर
Yeah.
ये जो हम लोग ऊपर तीनों कंडीशन लगा के निकाले हैं, ये क्या मतलब क्या पूछा रहेगा तब तीनों कंडीशन?
They will ask you. See, in the question they will ask you what is the deflection, what is the change in length, okay? What is the stresses in concrete, what are the stresses in steel? Okay, so you have to find all these things with the help of this formula, okay? Okay.
स्टील रिफोर्समेंट सर, स्टील रिफोर्समेंट का क्या फॉर्मूला है?
Steel reinforcements is look like this, okay? This is concrete, okay? So area of circle is nothing but pi d square by 4. So 1 bar area is this, area of 1 bar is this. You have given 4 bars, so you multiplied with 4 to find the area of steel. 4 into,
ये मतलब जो ए स्टील लिखे हैं वो आपका वो रिफोर्समेंट है?
yeah.
और वो ए कंक्रीट मतलब कंक्रीट का है?
Yeah, area of concrete.
ओके सर.
Okay. So last question is a steel plate E and mu is given to be subjected to a uniaxial load that causes a normal stress sigma. Okay, knowing that before loading a line of slope is in the ratio of √3:1. Okay, if I open √3 it will be 1.372:1. okay, is described on the plate. The slope of the line when sigma is equal to 200 MPa is asked. Okay. Okay. See, first of all, by seeing the question, you have to understand what the question means is that, see, long before you have studied reference configuration, current configuration. Okay. So now you are saying that in reference configuration, okay, the slope is in the ratio of this thing. Okay. Okay, I will just make a cube. They are saying the slope of that line is in the ratio of √3:1. Okay. √3 is nothing but 1.732 value. Okay. Okay.
Yes, sir.
This is before loading. So now they are saying that after loading, it will certainly changes its angle. Same cube. Suppose it will go here, this thing, and before this is this thing. Okay. What is this change in angle? Theta. They are asking this thing. Okay. Okay. This is reference. This is current. Okay. So first of all, they have given us stress. Okay. Uniaxial stress. So what is the stress matrix? 200 0 0 0 0 0. Okay. You know, when E and Poisson's ratios are given, how to find epsilon? Epsilon is nothing but 1 plus nu upon E into sigma minus nu upon E trace of sigma identity matrix. This is the formula. This is we have seen in previous week.
Yes.
So now we'll calculate the epsilon strain. 1 plus 0.3 given. Okay. 200 into 10 to the power 3 Newton per mm square. Just now I told you how to convert 200 GPa to Newton to mm square. Newton per mm square. This is nothing but 200, 0, 0, 0, 0, 0, 0, 0, 0, minus 0.3. Given value 200 into 10 to the power 3. This value. Trace of sigma is nothing but this addition of diagonal elements into 200. Identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. Got it up to now?
Yes, sir.
We just multiply this value inside this matrix and this value inside this matrix. Okay.
Okay, sir.
What you will get? You will get
सर पहले तो कॉमन कर लेंगे
1.3 into 10 to the power minus 3. 0, 0, 0, 0, 0, 0, 0, 0. Okay. Minus. See, this 200 will cancel out with this 200. So what left? 0.3 into 10 to the power minus 3. 0, 0, 0. 0.3 into 10 to the power minus 3. 0, 0, 0. 3 into 10 to the power minus 3. Okay, got it?
Good.
Finally, strain matrix will be equal to, just subtract, this is nothing but 10 to the power minus 3, 0, 0, 0, point minus 0.3 into 10 to the power minus 3, 0, 0, 0, minus 0.3 into 10 to the power minus 3. This is the strain matrix you got. Okay? Got it? Now they have given you slope value. What is this? Ratio. Root 3 is to 1. Okay. So see, they have given you this thing. Root 3, which is equal to 1.732 is to 1. Okay. So what is the theta value? This is theta reference value. So tan theta reference will be perpendicular upon base. So theta reference you will get as 30 degree. Tan 30 degree is 1 by root 3 only. Got it? You got the reference angle. What you have to find? You have to find the current angle. Okay. Okay. Since you got this reference angle, we can find the vector of line in which direction it is oriented. How to write? A vector. See, suppose I will say this line as A line. Okay, and this line I will say as B line. Okay. So what is the position vector of A? Position vector of A is nothing but cos theta into Ex plus sin theta into Ey. Okay. Theta you know. This is theta reference only.
Yes,
okay. So just put the value.
Yes, sir.
You will get cos 30 is root 3 by 2 Ex plus 1 by 2 Ey. This is the position vector of A line. Okay. Now you have studied one more thing, that change in angle, which is nothing but theta current minus theta ref, is nothing but 2 epsilon A dotted B. Okay, A dotted with B upon sin theta ref angle. This we have studied in second or third week, I suppose.
Yes,
this
sir.
formula. So now you know epsilon matrix, you know A direction, you know B. You have to find the angle with respect to Ex direction. So B is given to you. Okay, Ex. In the assignment question also B is Ex only. Okay. Okay. So now what is delta theta now? It is equal to 2 sin theta ref. Sin 30 degree is nothing but 1 by 2. Okay. Epsilon matrix we got as 10 to the power minus 3, 0, 0, 0, 0.3 into 10 to the power minus 3, minus 0, 0, minus 0.3 into 10 to the power minus 3. This is epsilon matrix. A is root 3 by 2, 1 by 2, 0. And B vector is 1, 0, 0. This is dot product. Okay. This is what we got. Here you have to do matrix multiplication, and then you have to dot product with the last one. What you will get? This 2 will go up, so it will become 4. So delta theta will be equal to 4. If you multiply these two matrices, you will get what you will get? Root 3 by 2 into 10 to the power minus 3. Okay. Minus 0.6 into 10 to the power minus 6, 3. Sorry. Minus 0.15. Okay. 0. Dot product is 0, 1, 0, 0. Okay. This is nothing but you will get 4 into root 3 by 2 into 10 to the power minus 3 into 1, which is nothing but 2 root 3 into 10 to the power minus 3. This is change in angle, okay? So your change in angle is nothing but theta current minus theta reference, which is equal to 2 root 3 into 10 to the power minus 3, okay?
It मतलब sir delta theta is equal to change in angle.
Yeah, which is nothing but theta current minus theta reference, okay?
Okay sir.
Theta reference is nothing but 30 degree we found, okay? This is in degree, you have to convert in radian, because this is in radian. Okay, this is in radian. So what you do is you will multiply by pi by 180, which is nothing but pi by 180 value. Okay, which is nothing but 0.5235. Okay. So theta current will be 0.5235 plus 2 root 3 into 10 to the minus 3. I will write in points now, which will be equal to 0.00346. So theta current will be equal to 0.5270628. This is theta current value in radian. Okay, got it. Now in that question, in the assignment question, they have asked you in terms of ratio. See, theta that they have given you as here, they are this thing, root 3:1 in this question. Okay.
सर असाइनमेंट में तो पूछा है सर 1:1, उसके बाद और कुछ नहीं पूछा है.
हाँ, so that ratio I am telling you only. See, theta reference is given you like this, root 3:1 in this question. So you have to mark it theta current also like this. So this should be 1 always. Okay. So here you find out this value, no? Just put 1 upon 0.5270628. Whatever the answer you got in your assignment problem, you just do this thing. Okay. So this value will be equal to 1.71828. Okay.
Okay sir.
Okay. So now the ratio is nothing but in the question of assignment 1 plus 0.71828 is to 1. You have to write this answer in your assignment, whatever you got in your problem. Okay. Got it? Understood?
ये नहीं समझ में आया हमको.
See, this thing you understood? What is the value of this?
नहीं सर, वही नहीं समझ में आया. थीटा करंट वो कैसे?
You understood this thing? Theta current value, how
yes,
you got? So yes, whatever sir. Value you will get, you do just divide 1 upon that value.
Okay sir. Okay.
You will get this answer for my question. This thing. Okay. This is nothing but 1 plus 0.7180828 is to 1 is this one is nothing but this value. Okay. This value is nothing but this value. Okay. Sorry. So 1.71828 is nothing but 1 plus 0.71828.
Okay,
Not getting it? Not getting it.
सर लेकिन एक असाइनमेंट वाला क्वेश्चन एक बार देख लीजिए.
Yeah, I'm telling you like this only. See, whatever I did my problem, you understood this thing? No, this thing you understood yes, or not? Sir. This thing tick mark.
Yes sir. Yes sir.
So now your ratio. see this ratio, theta current ratio is 1.71828 because height is 1. Understood this thing?
Yes, sir.
So you can write this thing as 1 plus something. 1 plus 0.71828. You can write this thing or not, like this.
Yes, sir. Yes,
this is same, no? So same thing you have to do in your assignment also, and this is your answer.
सर लेकिन असाइनमेंट में जैसे आप इस क्वेश्चन में 1 रेशियो वो किए थे, इधर क्या कहते हैं, कहाँ गया?
See, in assignment, your ratio, this ratio has been given equal to 1. This U3 value is given to 1.
हाँ, केवल 1 रेशियो 1 दिया है.
हाँ, so you have to substitute accordingly, na, root 3. You substitute. You just follow this question. You go back to this lecture. You again watch this problem, and then just do with your assignment thing. Okay.
तो सर ये जैसे आप रूट 3 का वैल्यू जो रखे हैं, मतलब जहाँ भी इस क्वेश्चन में रखे हैं, हमको तो सिंपल उसके जगह पे 1 रख देना है.
Yeah. But your angle will change. See, here angle is 30 degree. Because 1 by root 3. Their angle will be 45 degree. Okay.
Okay.
So just follow this example to solve your assignment problem. Okay. You are getting my point?
Okay, sir.
Okay. So this is the required thing. Okay. For this week's assignment and lecture. Okay. Hope you understood the things better.
सर ये ऊपर वाला जो क्वेश्चन था उसमें पॉइंट बी पे डिस्प्लेसमेंट कितना आया है?
ऊपर वाला क्वेश्चन, which this one?
डिस्प्लेसमेंट कितना आया पहले क्वेश्चन में पॉइंट बी पे? तो डिस्प्लेसमेंट कैसे नहीं?
1 second. No, you can go back and see the question 1. Okay, I have explained you this thing. Okay. See, I'll tell you once more. Okay. See, this is a problem we have solved. Okay, this question 1.
Yes,
okay, gap has been given to you. Okay, and other required details like diameter of AB, diameter of BC, and modulus of velocity for AB, BC is given to you, and thermal expansion has been given to you, coefficient of thermal expansion. Okay. So now epsilon observed will be epsilon mechanical plus epsilon thermal. Okay.
इसी को डिस्प्लेसमेंट करते हैं सर.
No, this is your strain. Okay, displacement is delta B. See, this thing is displacement.
Sir.
Okay. So this we have found out in this question with the help of this equilibrium conditions. Okay, and strain relations. Okay. So you can go back with this lecture again. See how I solve this question 1 again. If you have doubt, I can help you. Okay.
Okay.
Fine. I have explained each and every step. Okay. You can see above cases also. For this case, I have explained 2 times before also in this lecture.
सर okay. कहने का मतलब अगर हमको डेल्टा बी निकालना है तो पहले क्वेश्चन में आप जैसे ई ऑब्जर्व निकालते हैं, पहले सब निकालते आना पड़ेगा तब डेल्टा बी हमको.
Yes.
डायरेक्ट
no, direct you won't get it. No, directly you won't get it.
Okay sir. Okay. ये रहा सर, आप डिस्प्लेसमेंट निकाले तो है डेल्टा बी.
Yeah, delta B I have calculated, but after getting all the other things.
Okay sir. Okay.
You have to follow steps. Then only you can get it.
Okay sir.
Okay. Any other thing?
No sir.
Okay sir. Thank you for coming to this lecture. Okay, we'll meet again next week. Thank you.